Okay, let's take a look at this example where we are going to find the area between the curve and the x-axis for that function 1 minus x squared, negative 2 to 2. Right? I drew a quick graph here. I know what it's going to look like ahead of time, but it's not necessarily required to graph, but it definitely does help. Now, if it's a function you don't really know how to graph, of course use a graphing calculator if you have one, but if not, you could do a quick table of values. If I plug in 0, I'd get 1, negative 1, I'd get 0, 1, I'd also get 0, 2, I'd get negative 3, and negative 2, I would get the same. Right? There is symmetry here. It is a x squared. We know that's a parabola because it's negative, it opens down. From college algebra, you should know that this 1 actually moves it up 1. Also, we could do this, more algebraically. One thing we're going to need in all of these is to know if it crosses the x-axis. Okay, so if it crosses the x-axis, that means y is 0, right? So we could solve that as well for something that doesn't come out, so evenly as this one that we just did this table. So we could factor this or add x squared either way, and then we need to square root. Remember, when you do a square root, you do need plus or minus, so that shows x equals plus or minus 1. And that's how we got these. Okay, those points are important, and then also knowing whether it's above the x-axis or below the x-axis. Those are the two things you need. You don't really need a perfect sketch here, but let's look at why you do need the things I just mentioned. Up until now, we found the area between the curve and the x-axis. However, everything we had done up to now had assumed that the function was always positive. Okay, we assumed that never did this function cross down below this x-axis, down here, right? So if everything is above the x-axis, it was always a positive area. We need to account the fact that this is below the x-axis, and we would get negative area. And when we get negative area, it's a simple fix. All we need to do is change the sign to a negative, to make it positive. Because remember, area is always a positive value. It will make sense in certain contexts to have this negative area down here for a net change. But for now, this one does say find the area between the curve and the x-axis. These negative areas need to be changed to a positive. So, really quick, the old way, this is wrong, but if we had assumed, we want area of a curve, we have 1 minus x squared, negative 2 to 2, 1 minus x squared dx, then we would integrate this, right? We get x minus x to the third over 3 from negative 2 to 2, and then substitute in 2, we'd have 2 minus 8 thirds minus, now substitute negative 2, that'd be negative 2, and then negative 8 over 3, negative, so positive 8 over 3. Alright, now we would have 2 plus 2 is 4, and then negative 8 thirds minus another 8 thirds, right, so minus 16 thirds. Getting an LCD, that's 12 minus 16 is a negative 4 thirds. Right, that doesn't make sense. If we're talking area, and I just integrated our old way, it didn't work. We get a negative value, and you can't just change it to positive. That is not going to work out. So again, the old way, this is because all functions were always greater or equal to 0. And if not, we restricted the bounds to make sure that they were. So you haven't encountered a problem that had a function below the x-axis yet. So creates a little more work. Here's what we got to do. We break this up. We have this first area, -2 to -1. So I'm going to go ahead and cross that out. It didn't work, right? I mean, that is a value in a certain context, but not this answer. -2 to -1, 1 minus x squared dx. Now, this was negative, right? It's below the x-axis. We just put a negative there. Then we have this positive value, okay? From -1 to 1 is positive, so we just leave it positive. 1 minus x squared dx. And then another negative from 1 to 2. Now, quick comment. We could note that there is symmetry here. So whatever value we get here is going to come out to the same value we get here. Okay, so we don't really need to do that integral twice. In fact, we could have just split this up and done from 0 to 2, right? And just looked at this area and doubled it. And then this area, dip below the x-axis in orange and doubled it. That would have worked as well. Maybe, save a step. But personally, I don't want a perfect graph. The more challenging the function is, I kind of want a rough sketch to see what I'm doing, and that's about it. All right, so we'll move forward. We know all of these are going to be the same integral, right? X minus x to the third over 3, x minus x to the third over 3, x minus x to the third over 3. But the bounds are different for each of these. These bounds, again, this one has a negative, and it goes from -2 to -1. This one's a positive, -1 to 1. This one's a negative 1 to 2. It's important to remember this entire piece is negative, right? So I put parentheses. All right. So substitute -1. We would have a -1, and then -1 to the third is -1 with another negative is +1 to the third. Okay. Minus, plug in -2, -2, and then plus 8/3. All right, let's look at this middle. Substitute 1. We'd get 1 minus 1/3 minus, substitute -1, -1 plus 1/3. All right, this one's going to be the same as the first, so I'll just kind of say, minus some value, whatever we get over here. And if you don't know symmetry, of course, just substitute. In fact, maybe even this one would be easier than this one here, right? I mean, backtracking, I guess, but oh well. 2 minus 8/3 minus 1 minus 1/3. So a little easier only because, right, 2 and 1 opposed to these negatives, but again, same value. Alrighty. Don't see that we can avoid these fractions, so I guess we'll go ahead and deal with them. -1 and 1/3 is a -2/3. Minus -2 plus 8/3 is a +2/3, -6. Yeah, so +2/3, but then we have that negative, so -4/3 and a negative is a +4/3. Okay, plus here we have 2/3, and then that would be -2/3 and another negative, so +2/3, so we get 4/3. And then again, this last piece here is going to be another 4/3. Okay, this isn't always the case where we get all three areas the same. In fact, looking at this graph, right, I would have never guessed what I had highlighted in orange below the x-axis would be the same area as what I put in pink up here above the x-axis, right? I mean, they don't match up at all, but they do come out to be the same. Interesting. So 4, 8, 12 thirds, which is 4, and I don't know the units. It's, math. Sometimes they make these random problems without units, whatever. So 4 units, whatever it is, squared, because we are an area.